Hello everyone, welcome to my channel. So today we are going to do Leetcode daily challenge, longest subarray with maximum bitwise AND. So let us first read this question. Then we will be checking about the constraints, and then we will be going ahead with what are the possible solution which could be there for this particular question. Then the implementation part with the possible edge cases, because anyhow in interviews as well we are always asked that what are the possible edge cases even before the implementation. And then finally the time complexity and the space complexity, and there only will check that if we could optimize it further or not. So on these four parameters we will be going to do this particular question. So let us start with the reading of this question. So now here you are given an integer array nums of size n and consider a non-empty subarray from nums that has the maximum possible bitwise AND. So okay, then next it says that in other words, let k be the maximum value of the bitwise AND of any subarray of nums, then only subarray with a bitwise AND equal to k should be considered. Return the length of the longest such subarray. The bitwise AND of an array is the bitwise AND of all the numbers in it, and a subarray is a contiguous sequence of elements within an array. So now, after reading this question, the question says that we are required to return a subarray, means basically the length of the subarray, and that subarray should be the one which has the maximum bitwise AND. So now before doing this question, we should be knowing about few of the concepts in context to bitwise operators. And this question which is there, it is purely based on the observations. It doesn't follows any as such patterns which are there, but basically this particular question is purely based on observations. Now here, if we check this first example, then second example, but before that if we check, the constraints are that the numbers which could be present in that nums array is up to 10 raised to power 5. So that means we can go at max for order of n solution or n log n, but not more than that, else it will give us TLE. And the second part which is there is that each number which is there in that particular array, that can be at max 10 raised to power 6, means the number itself. Now in the part of this examples which are there. So now here even okay, let us first read the example, then I'll explain the concepts which are there. So here nums, this particular array which is given to us, now the output is 2. So as per the explanation what they want to convey, the maximum possible bitwise AND of the subarray is 3 and the longest subarray with the value is 3,3, so we return 2. So because this subarray length is 2, so that's why 2 is being returned. And how we chose this particular subarray, out of means this whole array which is there, we got this particular as that subarray which has the maximum bitwise AND. So that's why we are returning true. Now in this 1, 2, 3, 4, the maximum possible bitwise AND of the subarray 4, the longest subarray with the value is 4. So we return 1. Now let us see, means in this particular only how we got this 3,3, and in this 1, 2, 3, 4 how we got the answer as just 4. That let us calculate so that it would be easy for us to deduce that how we are required to code our solution. So now here let me see. Constraints we have checked. Now the part is about the possible solutions. But anyhow, this particular question is all about implementation. So rather than going ahead with possible solution, we are required to observe that what exactly we are required to do here. So now this is the example which is given to us. Let me change the color of this font. Selector. Sorry, I'm not able to get that. White. Fine. Now it would have been visible to you all. I have just copy pasted that example itself. That is what I have done. So now we just need those examples, and that is all. We don't require any sort of explanation. Now, first thing. Now the thing is that how we do AND. We all know the bitwise AND operation. So see, if there is 0 and 1, so answer would be 0. If there is 1 and 0, the answer would be 0. If there is 1 and 1, the answer would be 1. If there is 0 and 0, the answer would be 0, right? So this is how bitwise AND is being done over the bits which are there. So now here, if we go ahead with this, I'll take because if I'll start doing, okay, anyhow, 0 0 0 1, this is for the 1. Then for the 2 it would be 0 0 1 0. Then for the 3 it will be 0 0 1 1, and anyhow it would be like this. So now if we go ahead with 1 and 2, if we do bitwise AND of 1 and 2, right, if we take that, so it will come out to be 0 0 0 1 0 0 1 0, and after bitwise AND it would be 0 0 0, means ultimately it becomes 0, right? Then if we go ahead and perform AND with this also, means this is 1, this is 2, this is the resultant which is 0, and this is that 3. So if we perform AND, then it will become also 0, right? So now if we just skip this one, and if we skip this one and we do the bitwise AND of 2 and 3, so in that context it would be 0 0 1 0 0 0 1 1, right? So the answer would be this, that is 2, right? So till now, means if we take all three together, in that context we are able to get 0. If we take this 2 and 3, we are able to get this 2, right? Now if we go ahead and check that what else could be done. So now here this 3 3 which is there, if we do AND of that, then what would be the answer? So if we do like that, so it will be ultimately 3 again, right? So here we got the other one which is maximum out of this. Now if we check 3 2, anyhow we have checked. Then if we check for 2 and 2, this would be 0 0 1 0 0 0 1 0, right? 1 0 0 0 1, it would be 2, right? And if we go ahead with all three that we have checked, so it was ultimately 0, right? So out of these, if we check here, when we are taking all three together, right, so in that context anyhow we are getting the least one here. When two differents are there greater than 1, two different are there, then here anyhow we are getting much greater than this. But when we take the greatest number out of all these, so we are getting that one as the greatest one which is there. Then smaller numbers, if they are together in this particular array, that is getting a smaller AND. Fine. So till now we have observed this thing, that the highest bitwise AND which we are getting, that is just because of the highest number which is present in this particular array. So that is the thing. Now if we go ahead with the second example which is there, 1 2 3. So because anyhow we need to observe that what all things are there, so after that only we can conclude something out of this. So now the second example which is there, 1 2 3 4. So 1 is written 0 0 0 1, 2 is 0 0 1 0, 3 is 0 0 1 1, 4 is 0 1 0 0, right? So now if we do bitwise AND of 1 and 2, we got there as 0, right, earlier which we had calculated. If we go ahead with all three, that is also 0, and if we go ahead with 4 also, that would be also 0, because when we do AND with any number it will become ultimately 0, right? So now comes the part, if we do AND of 2 and 3, that was 2 which we calculated earlier. Now if we do AND with 4 also with this, because here we hadn't checked that, right? So the resultant of that was basically 2, right? 2 and 3, the resultant was 2. So now if we do AND with this, it will ultimately become 0, right? So if we do AND of all 3, it will become 0. So now if we do AND of 3 and 4, what it will be? Let us check. It's 0 0 0. Again it became 0, right? So here also it is 0. So now in all these, we are getting 0 only for each subarray, except for the part of 2 and 3, where we are getting the bitwise AND as 2. But now if we check for the individual ones, then what we are getting? Anyhow, 1 is smallest, 2 is greater than that, 3 is greater than that, and 4 is greater than that. So here, if we choose 2 comma 3 as the subarray, that will give us 2 as the bitwise AND. But if we choose the 4 itself, it will give us bitwise AND of 4, right? And that is the largest number. And in the previous example also, it was the largest number which is there that was giving us the maximum bitwise AND. And here also the largest number which is there, that is giving us the maximum bitwise AND. So after observing this, that in a particular array, means whatever numbers which are given to us, so whichever would be the largest number, that we need to check, and that largest number will be giving us the largest bitwise and if that particular largest number which is there, if by chance it is present like multiple times, right, so that subarray we can take and we can return that length. So here the answer would be 3 and here answer would be 1. So that is the thing. Means basically in this particular, after like getting more examples out of these examples, means first checking for these examples, when we got the similarity that yeah, the largest number in the first example was giving us the largest bitwise and the largest number in the second example was also giving us the largest bitwise AND. So basically after checking these things, we can deduce this particular question to this thing, that this question is not about figuring out the largest bitwise AND, but this question is basically about figuring out the largest numbers which are there in this particular array and returning the length of that particular subarray which contain those largest number. And now the question, when it boils down to that, means basically return the largest numbers subarray, means basically the length of this we are required to return. So this is what the question boils down to for this particular question. And when it boils down to this particular thing, now what we are required to do? We are now required to figure out the maximum number which is there and need to check that what are those consecutive places where that particular maximum number exists, and we need to just count that length and return that. So this is what we are required to do ultimately in this particular question. Means if you observe this particular question, it's like that you would be thinking that yeah, if you don't have that much knowledge about bitwise, or you have like, you feel like you're not that much strong in bitwise operations and so on, then surely you will just give up. But if you observe properly this particular question, that because anyhow simple and or negation, these operations we are always good at, because these are just the base of bitwise operation. So if you just observe all the examples and then just check that how we can reduce this particular to something else, then we will be easily able to get our answer. And after we are able to get to this particular conclusion that this particular question boils down to this, then it becomes from a medium level question to easy level question, because we easily know that how we need to code this particular thing. So now I hope you all are clear with the concepts being used in this particular, and how we boil down from the observation a medium level question to easy level question. So now after this comes the part, means the next thing which we are required to do is, so now here constraints are done, possible solution after the observation, right, it got boiled down to that we are required to figure out the length of largest numbers present consecutively. So that is the only approach which we are required to follow here. Now, implementation with the possibly edge cases. So now the implementation which is there, that is this only, that we are required to figure out the largest number, fine, and then we need to check the what are the means that largest number, if we found that more than one time, then are those all together, means are those consecutively present in this particular, that would be the thing. And in that I don't find any possible edge case for the same. And the further time complexity and space complexity of the same would be, first thing would be about figuring out the maximum number, that will take order of n time. Then second thing would be again iterating that particular loop and checking that how many times and where that particular maximum number is present, and if it is present consecutively, then what is the length of that consecutive subarray which is there. So overall it becomes order of n solution only. And the space complexity, anyhow we won't be using any extra space because we are not storing anything in external data structure. We are just taking variable, storing the maximum number in that, and then checking that where we are able to figure out the consecutive places where that maximum number is present. So this was all about this particular question. So now next part about the implementation. Now I'll show you the implementation part for the same. So here, now this is one of the method which means this max element. This is one of the method. This max element basically will figure out in this particular nums array which is the maximum element, and star will help us to get the value of that particular maximum element, and that will be stored in this maximum element. Now by either we can do by this, but if in interviews we are not able to get that what was the syntax of the same, we can switch back to a naive method, that order of n loop, and just iterate and get the maximum number. Now here the longest, this would be for the length part, and what would be the current length, just for the part of comparing them. Now we will check for each number, if that number is equals to maximum element, then we will increase the current length, and we will be checking that now what is the maximum out of that, the longest which was earlier stored or the one which is currently there. Else if we are not able to figure out the maximum element, then we will be making our current length equals to 0, but anyhow in the longest it would be stored whatever was the longest length, right? And then at the end we will be returning our longest length as the answer. And this is how we were required to do this question. If any doubt, you can comment that down, and yeah, if you have any other possible solutions or anything in your mind, you can comment that down as well. So this was all. Thank you.